Okay, so Bizarre Furhead and our mother are playing solitaire. That's right. And then tonight, going to do a little bit of work on this freezer. Got something in there that's not working right. Here is the average ice maker from a household freezer. And this thing is not working properly. Occasionally, it'll make ice just like it's supposed to. But sometimes, for whatever reason, after completing a cycle, it just totally stops working. And when it does stop working, what one can usually do to jolt it back into life is to lift up this stop lever and let it slam back down. So I'm wondering if maybe there's not a dead spot on its little timing motor. Oh, look at this. Can't believe how cleaned up the fridge is around here. And the kitchen too. Now, the first thing I ought to do to get ready to work on this thing properly without hurting or maiming ourselves unnecessarily is to go ahead and shut the refrigerator off and then go around back. Let's see here, go around back. I'll tell you what, one of these days that walking on my knees business is going to catch up with me. And unplug the refrigerator. Anyway, it's a good idea to unplug these things because the last time that I worked on an ice maker, it turns out that the heating element had a fault, and it was my aunt who noticed this first when she happened to touch the refrigerator and the electric stove at my grandfather's house. The stove was grounded, the refrigerator was not, and she got a shock. And I was systematically ruling things out, trying to figure out what was going on, and I didn't know what was going on until I reached around back of the refrigerator to test a wiring harness, and I touched a copper water line in the body of the fridge, and I had one heck of a painful sensation across my left hand. And then I knew immediately what was going on. So that's why outlets with a connected safety ground are important, and that's also why I'm going to unplug this thing before I pull this ice maker out of here and examine it. What had happened to that other ice maker, in most ice maker designs, they need a way to assure that the ice won't freeze solidly to the bottom of the tray that it's being made in. So there's this little heating element here that provides just enough heat to keep the ice from sticking so that the ejector blades up top, which sit here and spin around on a timed cycle, can actually eject the ice without issue. And on that other one that shocked me so terribly, pretty much, yeah, this heating element had actually rotted in two, and I was amazed that it was still working. But if the outlet had been properly connected to a safety ground, as it is now, the refrigerator would have popped a circuit breaker almost immediately when this happened, instead of being a hazard. To keep any food from potentially rotting while I work on the ice maker, the fridge can be plugged back in and turned back on. It'll just work as normal, and it won't make any ice automatically. I probably ought to find a way to cover that thing up somehow, but won't worry about it for right now. Before blaming the ice maker too much, one should definitely make sure that the freezer is getting cold enough and that the unit is operating properly, i.e. that the refrigeration system is doing what it ought to do and the temperature controls are set to reasonable values. And also, because in any refrigeration system, when you make cold, you have to get rid of hot. You need to make sure that your condenser coils are clean, and if they're cooled by a fan, you need to make sure that that fan is working and can move sufficient air across them. Now in this case, all those things check out with this fridge, so it's back to the ice maker. The ice maker hasn't totally dried out yet, but in the meantime, inside this little cover here that covers the gearbox and the motor and switch assembly, there is a schematic that explains electrically how this works. Now interestingly, and you can just barely see it, and by the time YouTube video compression gets done, maybe you can't see it at all, but interestingly, the schematic does not go so far as to show the normal states of the switches. So some investigation by opening this thing up and checking with a multimeter or seeing if it's printed on the switch bodies will reveal the normal position of the switches. It's also possible that this thing could simply be having problems with moisture having built up inside it and causing electrical conductivity issues, because this motor assembly is right out in front of the freezer door, and it's one of the first things that gets hit with a blast of warm air when that door is open. So there could be condensation built up in here that's messing up the works. In fact, I'm certain there is, because there is water dribbling out of this thing. So I'll let it dry out a little bit more, and then I'm going to take it open and examine those switches. My hunch, given that sometimes playing with this arm and letting it do that can cause the unit to start up again, I'm thinking that it's something to do with the arm switch, the stop-start switch, that's causing problems. It's either that or I feel very strongly that there could be a motor issue here. However, if there's a motor issue, I'm not sure that I can obtain the correct type of motor all by itself. I may simply have to buy another one of these assemblies or check and see if somehow this gearbox part is a service part, which I really doubt that it is. Here, after a careful investigation, is this pesky ice maker. And I went ahead and I took this assembly off. What I didn't realize when I was doing so, and what very nearly cost me a whole lot of trouble, this little arm that comes out is backed up by a spring that's carefully been wound around it. Without this metal plate through which a hole is drilled to support it, this thing was free to wobble around in there. And so one of the first things I ever did was I shifted this thing to see what change it would induce on the mechanism and to see if the switch was operating reliably. All of a sudden, ping! The whole thing came flying apart. And it was only by a number of experiments that I finally got it put back together properly. If this should happen to you on your General Electric ice maker, the proper way for this spring to go is with the long part against this plastic body and the short part actually wrapped around the curvature of this shaft behind this metal plate. If you ever are unfortunate enough to have this happen to you, and I sincerely hope that you're not, you'll see what I mean very soon. After I got that little problem fixed, I proceeded to test the heck out of the switches, and per an ohmmeter test, I simply couldn't make them fail. I played with them, and they all seemed to make and break reliably, but I went ahead and I popped their little plastic casings apart after carefully removing them, and I hit them with contact cleaner and gave them a little buffing on the switch surface, so if they have been exposed to arcing over the years or something along those lines, if they are causing problems, that should help to fix it. Now, while I was working on this, I discovered another little problem, quite by accident. I was playing with this big drive gear here, and here's what's going on with this. This is the gearbox output from the synchronous motor up here, and it drives the gearbox, and the gearbox in turn drives this little gear here, and then the little gear in turn drives this big gear, which drives the ice ejector tines out there. Well, I got to looking at this, and I realized that there was quite a bit of slop in the mechanism. You see that? I didn't think that could possibly be right. This small gear rides on a keyway, and it seems to me almost like that keyway has become stripped out and allows for slop in the mechanism. You can kind of see what the ice ejector tines are doing back there when I turn it. Well, I don't know for sure if that can cause this thing to not work, but it certainly shouldn't be doing that. And so I turned to the internet with this information and did a little bit of a web search to see what I could come up with. And after looking through a number of pages, I did indeed discover that this is a known problem with these mechanical type General Electric ice makers. And seemingly the fix is to carefully lever this gear off of here, being sure not to distort it, and then to clean this shaft so it is free of any oil or anything else, and then apply just a little bit of super glue to the hub, and then plop the gear back on, let it set up for a little bit, and then put the machine back into service and see if it works. I don't know if that's enough to throw the operation of this thing off, but I can say after having run this thing through a complete cycle by carefully inserting a screwdriver here and just running it through a cycle slowly and carefully to avoid stripping or damaging anything, because this is intended to run slowly, it does seem that the hardest time for this mechanism is right at bottom dead center, when it's got these tines positioned down underneath and it's getting ready to scoop the ice out. It's actually scooping the ice out and getting ready to flip it over and dump it into the ice bin, which goes off this way. During that time, the amount of effort required to drive this gear with this screwdriver, just like this, increased quite dramatically. And so I'm thinking that's the most stressful point, just prior to mechanism reset. I'm not entirely clear, but then again, I'm not an engineer, as to why doing this would jump-start it, unless maybe it restarts the clock or resynchronizes the mechanism. Maybe it gets into a confused state or something. I'm not entirely sure, and it's too late to do anything about it tonight, but what I'm going to do in the near future here, probably tomorrow, after I get done with work, is I'll go ahead and I'll pop this little gear off, I'll buy some super glue, or see if I can't find some of my super glue, although I haven't found it yet, and I'll go ahead and I'll glue this gear back on here, I'll hang this thing back up in the refrigerator, plug its little power cord back in, run the water tube in up here, and I'll just see if over a period of a week or two, if this thing is once again reliably making ice. It is my hope that it will be. I believe it will be a relatively easy fix between either the electrical switches or this little gear out here. So stay tuned for part 2 in a little while.